Right, so in this video I want to take you through lots of examples of sine rule, cosine rule and the area formula. The topic as a whole is called non-right angle trig because we're doing trigonometry, but it applies to triangles that don't necessarily have a right angle. This is a picture of a triangle that doesn't necessarily have a right angle, and it's a nice general situation. You're given these, well, you used to be given these formulae, and you're no longer given these formulae, but this is how they're printed on all the posters that say these are the formulas you've got to learn. The top one's called the sine rule, the middle one is called the cosine rule, and the bottom one is called the area formula. I plan to take you through how all of these work, and I'm going to go quite quickly because I want to get it all in. I don't want the video to be, half an hour long. I would forgive you if you regularly paused, you rewound, you listened to bits again, that's fine. But I'm going to go quite fast to try to cover all the various things. The most important thing about these formulas is the little letters are the side lengths, so little a, little b, little c, they represent the side lengths, and the capital A, capital B, capital C, they represent the angles, which are at vertices A, B and C. So we'll also say that this is angle A and this is angle B, and so on. The important thing about the labelling is that we have opposites going on. So side little a is opposite capital A. There's a few redundant things that we're not that interested in. So for example, up here we're given sort of 3 parts to the sine rule, but you only ever use a pair of them. So you look for a pair of opposites. You don't need 3 things to be opposite in order to work out the problem. It could be those 2, it could be those 2, but you only ever use a pair of them. This doesn't have to be a squared, as in the one in the top right. You could have this as b squared equals a squared plus c squared minus 2ac. That would work as well, but I'll take you through that as we go along. So my first 3 examples are all using sine rule, and you'll see 2 of them on your screen now. The third one's just below and doesn't quite fit on. So the sine rule is saying that when you have opposites, it's stated like this. We've got a over sine A equals b over sine B. I don't need the third one as well. It's just saying that if you take a side and you divide it by the sine of the opposite angle, you always get the same number. It doesn't matter which ones you do. So that divided by sine that will give you the same answer as that divided by sine that. Now that's useful because I can now write an equation. So for this particular one, these are opposites, aren't they? Okay, so I've got 3.7 divided by sine 80 would give me the same answer as doing side x divided by sine 40. Okay, now I'm trying to figure out what x is, how long that side is. So to get x on its own, I need to undo the fact that at the moment it's been divided by sine 40. So let's multiply both sides by sine 40. So I used to have 3.7 over sine 80. I'm going to multiply it by sine 40, but if I multiply all of this by sine 40, it just undoes the division, and I'm left with x, and that was the whole point of doing that multiplication. I now just machine this entire thing into my calculator. One really crucial thing, make sure your calculator is in degrees. If it isn't in degrees, on the class whiz you press shift setup, and its angle unit you choose degrees number 1. On the older calculators it's still shift and then that one there, shift and mode, I think, on the old calculator, and you can choose your angle unit that way. But I am in degrees, which is good, so I'm just going to type in this 3.7 blah 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 thing. So it's a fraction button, 3.7 all over sine 80. You need to close the brackets, otherwise it gets confused. So press right to get out of the denominator. Then it's a times sign, then sine 40. And this time I don't think it matters if you don't close the brackets, but I'm going to. And that equals 2.415 blah blah blah. It's always a good idea to put the full thing from the calculator, or at least the first few things from the calculator, until you round it. I haven't specified. In fact, for the whole of this video, I'll do 3 significant figures. Make sure you get the units right as well. So in this particular one, I've worked out a length. This length was in centimetres, so this length will be automatically in centimetres as well. So I get 2.42 centimetres to 3 significant figures is my length x. In question number 2, this is sine rule again, but notice how I don't have opposites. Well, I sort of do. I've got a pair of opposites there, that the side 9.8 is opposite angle 32, but my x is opposite this angle, which I don't know. That's not a problem though, because I know that the angles in a triangle add to 180, so I can work out that missing angle. So if I do 180, take away 48 and take away 32, it's 100 exactly. So that missing angle there is 100. And now I can do the problem in the exact same way as before. So my opposites are, that's opposite that one, isn't it? So I've got x over sine 100, and these are opposites, is 9.8 over sine 32. To get x on its own, well, at the moment it's divided by sine 100, so let's multiply both sides by sine 100. And then just type it straight in. So that's fraction button 9.8 all over sine 100. You must close the brackets. Oh, sorry, sine 32 on the bottom, wasn't it? My bad. Okay, 9.8 over sine 32. Press right to get out of the bottom of the fraction, times by sine 100. 18.212, blah, blah, blah. And if I go 3 significant figures, that's 18.2. My units this time are meters. So that's my answer. Now question number 3 is also an example of using sine rule. I know it's sine rule because I've got pairs of opposites going on. I've got that's opposite that, that's opposite that. So it's definitely going to be sine rule to work this out. This time I'm asked to find an angle, and it's probably a good idea to state the sine rule the other way up. So you're used to having the angle on the bottom, but if you state the whole thing the other way up, put your sine A's on the top and your sine B's on the top, it's still a true statement. You've taken the reciprocal of both sides. It's just a rearrangement of the sine rule. So it's completely legitimate to have it this way up. And if you're trying to find an angle, in fact, I would recommend that you put the sin angle on the top and the sides on the bottom. Okay, I can substitute directly into this now. These are my opposites. It doesn't matter which one you call the A and the B. I could have that this is my A and this is my B, or this is my A and this is my B. Doesn't make any difference. Let's call this the A down here, so this will be side A. So I've got sin x over 3.5, just make sure they're opposites, is sin 47 over 3. This time there's 2 things to do to undo this. I want x on its own, it's been sinned, and it's also been divided by 3.5. So let's start by multiplying both sides by 3.5. Just going to type that in the calculator and get a decimal for that. So that was sin 47. Oops, my bad. Over 3, and then press right to get out of the denominator, times by 3. That's 0.731, blah, blah, blah. Sorry. There we go. That's the correct calculation, isn't it? Okay, it's hard to get everything on the screen all at once. However I hold it, I can't quite do it. So it was times by 3.5, times by 3.5. So I typed it in wrong initially. But there we go, I've got it right now. So 0.853, blah, blah, blah. So now if I want to undo the sin, I need to do shift sin, sin minus 1. So to get x on its own, it's sin minus 1 of that previous answer. So I just get on my calculator, shift sin of previous answer, and I get 58.566, blah, blah, blah. That's one answer, which I'll round in a minute. But remember, when you're doing inverse sine, that's just what we call the principal value. It's possible that there's a second answer as well, And to get the secondary value for sine, it's 180 minus the principal value. So I need to check it. This might end up making no sense, but I need to check, does this work as well? 121.433. Blah, blah, blah. Let's think about it. Well, this one's got no problem. There's absolutely no reason why 58 and a bit can't be that angle there. But could this angle be 121.433? Let's have a think about it. Well, if it is 121.433 and the other angle is 47, then that's 168, and that does leave space for a third angle. It would be quite small. It would be only 11.5-ish, but there is enough space for it. So actually, both answers are completely acceptable. This was an example of what we call the ambiguous case. So it's fine, both work. So you need to give both if you want full marks. So x could be 58.6 degrees to 3 sig figs, or it could be 121 degrees to 3 sig figs. It's ambiguous, so you must give both. A bit like when you solve a quadratic equation, if you have two answers, you give both. Same thing here, there's two possible values for the x there, so you give both. Now, these two questions are not sine rule, these are actually cosine rule. You might begin to recognise cosine rule because it involves all three sides and one angle rather than opposites. I've got one pair of opposites there, and then there's no more opposites. So it can't be sine rule, it's actually cosine rule. But to be honest, it doesn't really matter. You can always just try stuff, and if the first thing you try leads nowhere, then try a different formula. It doesn't matter too much if you don't instantly recognise which formula to use. So cosine rule is stated as a squared equals b squared plus c squared. So far it's just Pythagoras, isn't it? Sorry, it's gone off the edge, my bad. Minus 2bc cos a. And in fact, if you work out cos 90, if the special case is that this is 90 degrees, that's just 0, and that bit disappears. So that's why Pythagoras works. Pythagoras is actually just a special case of the cosine rule when your angle A happens to be 90, because you know Pythagoras only works for right angle triangles. But I digress. Let's do this particular question. What you should notice about the cosine rule is that we've got B and C, the side lengths B and C, they appear twice over on the right hand side, but the length A is special because it only appears once and it's over on the left. Your length A, the one that you put over on the left hand side, is the one that's opposite angle A. If you've got more than one angle, you might have a choice, but here we've only got one angle, so that's my A. That's the thing that's going to go over on the left for this particular triangle. So I substitute the numbers in. I've chosen my B to be the 3.2 and my C to be the 5.4, but I could have done those the other way round. I'll now put it straight in the calculator and see what happens. And it gives me this result here, so 2896 point blah blah blah. Okay, but that tells me what x squared is, so I need to and in fact, I've just realised that would be a really silly answer. That's far too big, even when you square root it. I'm not going to get an answer that's a bit like 3.2 and 5.4. So I just recognised my own mistake. I typed in 54 rather than 5.4 accidentally. And now that's typed in correctly. And we should arrive at 9.173, which makes much more sense. But the point remains that by substituting straight into the formula and typing it in, all I've worked out is that the square of this length. I've worked out x squared. I still need to square root both sides. So just on your calculator, square root answer, we get 3.028 blah blah blah. And once again, I'm going to give my final answer with the correct units to three significant figures. So we'll be in kilometres, and that's going to give me 3.03 kilometres to 3 significant figures. Question 5 is also a cosine rule question, but I'm finding the angle. You can substitute directly into this formula, and that will get you a mark, but it's then quite hard to proceed from there. If you substitute that's your A, that's your B, that's your C, and that's your capital A into this formula, it's a little tricky to rearrange. It's actually worth memorizing the rearrangement. Which is this. And like before, when A was special because it was over on the left-hand side, A is special here because it's the only one that you take away. In the formula, B and C appears twice, squared on the top and not squared on the bottom, but A only appears once and it's taken away on the top. So A must be special, and once again, A is the one that's opposite the angle we're using. So I've got, that's my capital A and that's my little a, and the B and the C doesn't matter what order you get those in. So I'll substitute in now, and maybe I'll call this one the B and this one the C, but you can go the other way around if you like, which is that. I'll type it in now. Typed it in, and that gives me, if I press SD, 0.339 blah blah blah, but that's just cos x. So to get x on its own, I need to undo cos. The opposite of cos is cos minus 1. So just do cos minus 1 of that previous answer. That's going to give me 70.164 blah 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 degrees. So if I round this to 3 significant figures, that's going to give me 70.2 degrees to 3 significant figures. When you're doing inverse cos, you don't have to worry about a secondary value. The secondary value is found we're doing 360 minus the principal value, and that's always going to give you something bigger than 180, so that would be daft. You only have to worry about the possibility of a secondary value, an ambiguous case, for backwards sine rule. You don't need to worry about it for finding an angle using backwards cosine rule. So these questions are not sine rule, they're not cosine rule, they make use instead of the area formula. And the area formula, recall, is that area is equal to half AB sine C. What's critical about this is that the angle C appears between the two lengths that you're using, A and B. So sometimes you know more than one angle, or you might know more than two sides, but if you want to find the area of a triangle, you have to do have two sides, and the angle is between the two sides. In this case, that's all we got, so we have to use the ones we're given. You're welcome to get the A and the B the other way around if you like, but that would have to be your C. So that's what it looks like. I now type that in the calculator, which gives me this result here, and that's just the answer. So 26.964 ... that tells me that the area is 27.0 feet squared. Slightly odd units here, but I wanted to mix it up a bit. Square feet to 3 significant figures. It's an area, so it's in squared units, right? Now in this last question, we're supposed to do this without a calculator. Okay, well I've got my area formula, which is half AB sine C. I know the left-hand side is supposed to be 18 root 3. I know my angle is x, and the A and the B are 8 and 9 in some order. So I just substitute that in. I've got 18 root 3 over on the left. I've got a half times 8 times 9 times sine x. I can simplify this on the left hand side because a half of 8 is 4 and 4 times 9 is 36. So let's just simplify the left hand side as 36 sine x, and I just got that by multiplying a half, 8 and 9 together. Just did that bit. If I divide both sides by 36, well 18 divided by 36 is a half. So I get half root 3, or root 3 over 2 is probably a better way of writing that. And you're supposed to recognise that root 3 over 2 is one of the special ones. So if I do inverse sine of both sides, think about it, you know that the angle which gives you root 3 over 2 for sin is 60. Or if you don't know yet, you should do. For the purposes of this lesson today, you could do that on a calculator. You do shift sine of root 3 over 2. You should get 60. But I've just done inverse sine, so don't forget there's another possibility. 180 minus 60 is 120. And once again, there's really no reason why it couldn't be 120. Most people are happy that that could be 60. Well, why not 120? It could be. 120 still leaves space for two other angles. So it's ambiguous. It's those two. I haven't needed to round it this time. I've got exact angles because I had this exact thing going on here, which was one of the ones that you learn about. Now finally, I'm going to go quite quickly with this one again. This is an example much like you had in your exam recently, where it's just a mixture of things. It was worth 5 marks in your exam. I guess this would be something similar. You just have to try stuff and work stuff out, and then the mark scheme is quite it rewards you for just trying stuff. Don't worry if you can't see like a whole route to the finish line. It turns out there's a couple of ways of doing it. You could start by looking at just this little triangle BCD. If you worked out this length using the sine rule, so we now know BD, you could then consider this top triangle. You would know that, 180 minus 93 gives you that angle, and you could just cosine rule to get AD. In fact, that is what I'm going to do. The other option is, if you started by looking at just this triangle, you could use sine rule to get this length here, BC. If you add the length BC that you've just found to 38, you now know this entire length AC, and then you could do cosine rule on the big triangle ACD, because you know that whole length, you know the 39, you know the 47, you could work out that length there. So there's a couple of ways of doing this. I'm going to do the first thing that we said. So I'm going to start by working out this length here, I'll call it X, on the little triangle BCD. Okay, then multiply both sides by sin 39 to get X on its own, and type it in the calculator. And apparently that gives me that X is 29.61, blah, blah, blah. So I've just written that over here. Don't round it yet, okay, because that if I rounded it now, I'd get a slightly incorrect answer. I'm going to square it and do stuff with it in a minute. And when you multiply it or square it, you're going to make that error bigger and bigger. So don't round it yet. We can still use the answer button. This angle in here must be the remaining 87, because 180 take away 93 is 87. So I can now consider just this top triangle, just triangle ABD. I'm going to do cosine rule on that triangle to work out this length. I need a new letter. I can't use X again, so let's call it Y. And I'm going to do cosine rule to work out Y. Now, when I type this in the calculator, I can just use the answer button here and here. So I'll show you what that looks like. Okay, so I've typed in 38 squared plus answer squared. That's my 29.61 number there. Take away 38 times 29.61 times by cos of the angle, which is 87 in that top left triangle. When I hit equals, I get 2203 point blah, blah, blah. And just like before, if I want to figure out y, I have to undo the squaring. So I just square root the answer. So square root that thing there, and I get 46.940, blah, blah, blah. I've worked out a length. These lengths are in millimeters, so when I round this, I get 46.9 millimeters, correct to 3 significant figures. And even though I tried to go really fast, that's still a really long video, so my apologies for that. You can now choose whatever you want to work on. You can do the basic stuff, or you can try the harder ones as I've specified on the Google Classroom. Okay, very best of luck.